Morning, everybody.
Morning, sir.
Good morning, everybody.
Morning, sir.
Right. Morning. All right. So, you can all see the screen? Online,
Yes.
you can see the screen?
Yes, sir.
All right, good. So what I have up here on the screen is basically the syllabus for the CSEC math, paper 1, paper 2 and paper 1, but over this side is the syllabus breakout for paper 1. All right, so there are 60 questions on the exam paper. 6 of them will be on number theory. 6 of them will be on sets. 8 of them will be on consumer arithmetic. 6 will be algebra. 6 statistics. 8 measurements. 8 functions, relations, and graphs. 8 geometry and trigs. And 4 matrices and vectors. All right. And there's also some transformation in there as well. I think the transformation will come in this section. Those 8. All right. So listen, we are all exposed to so many past papers. Really and truly shouldn't have those past papers, because CSEC really intended for those papers to be taken back. Right? But you know how it is, everybody beat the system, and so almost every exam past paper for paper 1 is available. Once you have the right connection, you'll get it. Nowadays, people just send it to my phone. I know that I teach and people just send it to my phone. Students send it to my phone, teachers send it to my phone, colleagues just send it to my phone, just get them. Sometimes I get 5 different copies of the same paper. I get the papers like minutes after the exam is over. Exam over and they just come onto my phone. That's the nature of things nowadays. So CSEC knows that. CSEC knows that the questions are out there. Now, in the past, they could give an exam paper with all 60 questions repeated, verbatim, word for word, no change. People who had access to multiple choice past papers in the past would be at an advantage. Still, I guess it's an advantage now. But back then, they would probably set a paper and don't need to make any change because so few persons would have any, if any at all. I remember there was a time, for example, you might have a particular year that nobody got. CSEC was efficient that year in ensuring that none of it got out and nobody had it. I was searching, but I couldn't find that particular year. That's how it was. But now, I mean, almost every single paper, by the time you ask a couple of colleagues, somebody send it and you get it. All right. So because CSEC knows that what they are doing, they are now making changes to the questions. Understand? They're making changes to the questions, and they're also setting new questions. Now, the thing is, even when they set new questions, they still are bounded by the syllabus. The fact of the matter is that multiple choice questions are a little bit more difficult to set than even a structured question. You understand me? Because there are not many different ways to set a multiple choice question. I remember now you have to be formulating answers. And sometimes your task, if I'm setting a multiple choice question, I'm going to put answers there that I know would result from certain mistakes. Because you really want to be able to identify the people who really know the stuff. So I would put the correct answer, yes, but then I will search for 3 other answers that I know, okay, a student is going to make this mistake. And he's going to make a mistake with a negative number. He's going to make a mistake here. He's going to make a mistake there. And I put 3 other questions, 3 other answers based on the mistake. Maybe 1 without answer, and then maybe 2 other answers that basically is aligned with the mistakes that I know people will make. And so it takes time. It takes time to do that. You understand me? But I still want to make changes to the questions. That's the fact of the matter, because they know that all the questions are out there available. It's not news to them. They know it. And they know that they do repeat a lot of the questions. And so what they have been doing in recent times is they've been making minor changes. It's almost I feel like it is deliberate. That they make some very minute changes to the questions. And what they do sometimes is leave the original answer there on the paper. So you read a question, and it looks like a question that you have seen on 10 past papers. But then there's just one little small change. They put a 2/3 to a 3/2 instead. They put a X where they would normally have a Y. They put up where we normally have down. Simple little changes like that. Right? And you might just miss it. Sometimes you read the first part of a question, and the difference is just in the very last line of the question. So everything stays the same. And then the very last line, they make a change. Sometimes what they are doing as well is they give you back the same information. What they asked for in a previous question, they give it to you in another part of the question, right? And asking for something that was a part of the original question. You understand what I said a while ago? So in the past, so they set a question in the past, and they would, for example, ask to find the height of a triangle. So they reset the same question, they give you the height of the triangle now, and ask you to find the base, ask to find something else. Right? Because it's easier for them to do that rather than to go and set a brand new question. So one of the main reasons I'm going through this is because I could just give you all those 29, 30, 40, 50 past papers and say, go through them and learn the question them and go and do the exam. You're sure to get at least 50 of them repeated. But what I don't want you to do is fall into this sense of security, which is false, that the questions are exactly the same. I want you to be guarded against that. I want you to be super careful. Oftentimes I see people come out the exam room and say, sir, you see one question what they're doing on this, that, and that, and that. Oh, me see the question, me see the difference, you know. I'm saying, yes, sir, you do it enough time and answer 5. And answer the 5, you know. But at that time, I can't even tell them. But that's all right. You understand me? But I get it wrong because the answer has changed, because the question has a change on it, and they have not recognized the change on it. Because what they do, they give so much of the original question and put just a minute change, difficult to see. So I want you guys to be aware of that. And I'm going to take the opportunity to go through some questions. And this bank of questions is like from the most recent papers that they have sent. And I try to pull out as many of the similar questions, put them all together, or doing it topic by topic over 4 days. Before I would do maybe a whole day, but this is so important. I want to do it in a period, I do it in periods that we can maintain focus. So I think it's better for me to do it in short sessions for 4 days rather than do it in 2 days for the entire day. All right, so that's why I've decided to do it in the short sessions for 2 days. So whenever I finish the first 2 topics, I hope we don't need 3 hours to do it. If we can do it in an hour and a half, 2 hours, all the better. But I just want to ensure that we cover each of the topics that you see on the screen here, topic by topic, highlight some of the changes that are there so you get a feel of what the changes will look like and how the change will manifest. And believe me, they will make changes. Your example that you're doing, there are going to be changes in questions on them. Right? There are going to be changes in the question. There are going to be questions on the paper that are almost the same as questions that you have seen and done before. And you're going to be tempted to believe that it is the same question. And you have to be mindful of it and be guarded against it and make sure. And that is why the strategy that we're going to be preparing and be using is one that we go to the exam paper at least 2 times. We're aiming to go to the exam paper 3 times, but at least 2 times. So after we finish these 4 days, 2 days before the exam, we're going to have a session where we're going to do 12 papers. We're going to do 12 papers, 12 different papers. We're going to do 3 papers in an hour and a half. Break. That's on Wednesday. 3 papers again in an hour and a half. Come back Thursday and do the same thing. 3 papers in an hour and a half. 3 papers in an hour and a half. Because I want us to prepare as if we're going to do the exam paper on Friday 3 times. If we don't get to 3 times, 2 times is good enough. But at least 2 times, but the aim is to do it 3 times. That means when you go through the paper on the exam day Friday and you finish, you're going to go through it again. You're going to finish before time, I promise you. You're going to go through it again. Carefully checking every question to the detail. Make sure that you have answered what they are asking. Make sure that in particular questions that are familiar to you, you look to see if there are any changes, any differences in them. Very, very important. All right, enough chatting. So let's go through this question. I promise you, from this bank of questions, a good majority of them will be on the paper, but with minor changes, with changes. All right. So today we're going to do number theory and we're going to do sets. That's what I said for today, right? Number theory and sets, right? Number theory and sets. Those are like the first 2 sections. Right, see here. Number theory and sets. All right, let's go. The aim is 60 out of 60 out in the exam, guys. Nothing less than 58 is good enough. And you need to start getting 58 consistently before the exam on Friday. Because if you can get 58 while you practice, then you get 58 in the exam as well. So we need to get to that stage. We're getting 58 by Wednesday. All right. Let's go. I don't know a lot of these questions are going to be that you see them before, right? Like this one, for example, very frequent on past papers. It says, what is the value of this 2? What you might see that on the next exam paper, and I might ask you what is the value of this 6. Or they might instead put 48612. Something like that, I make a change like that. And then ask you what is the value of the 2. You get me? And then the value of the 2 would not be the same anymore. You understand? So you have to look out, careful. All right. So for this one, the 2 is in the hundredths place. So it is like 0.02, which is 2 over 100. We have to look out for changes, guys. That is that one. All right. Next one. What percentage of 50 is 10? What percentage of 50 is 10? Now, this can be done multiple. You can do it like almost like a ratio. All right. When I was in prep school, they would say, what percentage of 50 in 10? So, okay, you put 10 and put what comes after the half, you put it on the denominator and multiply by 100. That's what they used to tell us in prep schools. It's like almost like a rote method of learning. And we just do it. What comes after the half, you put it on the denominator, put other number on top. But sometimes the question word in a way where this rote learning method really is not safe. All right. So as an equation, it could be what percentage, and you're trying to find the percentage. So you could say, okay, x over 100, that's a percentage of the 50 is equal to 10. And you're trying to find x. Can be done that way. All right. It works out back to the same answer. Another way to look at it is could say, okay, do it like a ratio. You could say, all right, what percentage of 50 is 10? So you could say, okay, 100% is equivalent to 50. 100% of 50 is 50. You want to know what percent is 10. So you want this side to come down to 10. Where you get this 50 to come down to 10? You divide it by 5. So if I want it to become 10, I divide this by 5. So I have to divide this by 5 as well. And then you see that when you divide this by 5, you get 20. So 20% is therefore equivalent to 10. So the answer is 20%. You have done that way. But if you do it the other way, 10 over 50 times 100, no problem. But this is the answer. Yeah? Anyway, you want to do it, my boss. Everybody gonna have 10 different ways to do it. I just showed it 3 a while ago. Yeah, man, that's okay. I can show you a quick way as well. I can say, for example, okay, what percent of 50 is 10? I can say, okay, 10% is 5. 10% of 50 is 5. What percentage therefore is 10? Must be 20%. 20% is therefore 10. Can look at it that way. You look at the numbers and know. If the number is 50, 10% is 5. So therefore, if 10% is 5, what percent is 50? 20%. So there are myriad of ways it can be looked at. Right? So whichever way you feel comfortable with, no problem. All right? So this is just one I'm leaving on the screen, but it doesn't have to be that way. There's another question like this with a change on a paper right over here. We say what percent of 40 is 8? And the same work. Same 20%. So again, we could say, okay, what percent of 40 is 8? We could say, okay, 10% is 4. 10% of 40 is 4. 10% is 4. So therefore, what percent is 8? If you have 10% is 4, then clearly 20% is 8. And so the answer again is 20%. So the same question and the change of values. Even the answers are the same. The answers are the same. 5, 20, 32, 150. See there? 5, 20, 32, 150. Somebody online has the mic open. Can you close your mic, please? All right. So you don't have to do it this way, guys. You don't have to do it this way. All right. You don't have to do it this way. All right. Next exam. There's another popular question. We're going to give you this to write in standard form. All right. Now, this is a very small number because it's 0.00 something. So it has to be 10 to the minus something is the answer. 10 to the minus what? 2 decimal places. You need to move the decimal point 2 places to get it there. So it's 10 to the minus 2. So it's 2.08 times 10 to the minus 2. If you want to work it out, you could say, okay, to get the decimal point here, I will have to multiply by 10 squared. That is just to move the decimal point to where I want it in standard form. Right? To move the decimal point to where it's supposed to be. Because standard form is when the decimal point is in a position after the first non-zero digit. You want the decimal point to be right after the first non-zero digit. So you want the decimal point to come right after the 2. So to get the decimal point there, we would have to multiply by 10 squared. I move it 2 places to the right. To balance out that multiplication of 10 squared, multiply by 10 to the negative 2. So this calculation here will move the decimal point for you. But to cancel it out, you have to multiply by 10 to the minus 2. So the result is this one. And then they say they give the same values, but then the size of the number is different. This is not a big number, it's in the hundreds. So you know, says no, the power is positive. So that one was no 10 squared. See there, 10 squared. This is it. If you want to work it out, you could say, okay, I need the decimal point to be here. Right? So you could say, okay, I need the decimal point to be here. 2 places to the left. To get it there, I have to now divide by 10 squared. I can say multiply by 10 to the minus 2 to move it back. So this will move it back for us. 2 places to the left. But then to balance out this 10 to the minus 2, I have to go now multiply back by 10 squared. Put in a different color. I have to go and multiply this result now back by 10 squared. You get me? So this will move the decimal point for you and you multiply the result by that. Some of these numbers, some of these questions don't really know working out. The number is in the hundreds. This means that 10 squared multiplied by 100. All right? And that is it. All right. This one now is a ratio. It says, in a school, the ratio of the number of pupils to teachers is 20 to 1. No, multiple ways to do this question. So we can say, okay, they said that the total number of pupils is 840. So we know what the actual for that is, 240. So we have pupils to teachers is 20 to 1. And the actual for the pupils is 840. So it means that I need this figure to come up to 840 to see what the actuals are. How do I get this up to 840? 840 means that this number becomes 84, don't it? I want this 2 to become 84. That's a change, because the 0 is already there. Look at it that way. So we have a 2 here. I need this to become an 84. So if I multiply that by 42 for it to become 84, this number, for that to become 84, I need to multiply by 42. So I multiply this by 42. When I multiply that by 42, this side becomes 84, becomes 84, and then the 0 on it. Because therefore to multiply by 42 as well. So when there are 840 pupils, there are 42 teachers. How many teachers are there? 42. Now, another question I could ask for this is now, what is the total number of teachers and students and pupils? You'd have to add these. They want the total number of pupils and students. All right. So look out again for this question where they actually now tell you the total number of teachers that you have and ask for the number of pupils, where they actually switch it around. All right. So you have to look out for that as well. All right. That one is that. Another ratio question. And these two questions are the same from two different papers. This one says a bag of apples can be shared equally among 6, 10, and 15 people, children, equally. The minimum number of apples that are likely in the bag is therefore the lowest common multiple. One of the lowest multiple of the 6, the 10, and the 15. This question is asking the same thing, you know. The same question, same answers. It says, what is the least number of apples that can be shared equally among 6, 10, and 15 children? It's the same question, worded differently. You're looking for the lowest common multiple. Lowest common multiple. For this one, it's going to be 30, right? 30 is the lowest common multiple. You're looking for the LCM. LCM of 6, 10, and 15. And when you're searching for LCM, usually start working from the larger one first. Working from the larger one first. All right? So from the 15, the next multiple of 15 is going to be the 30. And you check if these are also factors of 30, or if 30 is also a multiple of those. 30 is also a multiple of these, and which it is. So you work from the larger one. Nobody waste time and work from the smaller one up. Work from the largest one. The next multiple of the largest one is 30. I'm just telling you what if you get other values. Look for the next multiple of the largest one first. And then you see if that multiple is a multiple of the other two, which it is. You get me? Work from the larger one. Work from the larger one. So the answer is 30. All right. So these are also 30 is a multiple of those as well. So the answer is 30. So far as I got, look like we're going to finish this session relatively early, you know. So I don't want it to be too long. Even though I put 3 hours on a thing, I don't want it to be too long. So when we finish, you guys are going to just do a paper or 2 for the rest of the time. All right? If we finish before the 3 hours. All right. Another question here. There's another popular question. I might see it again later down. So they are telling us that this times this equals that, right? And then they ask us for this. Now, some people proceed to actually try and calculate this, you know, which really is a waste of time. You don't have to calculate it. All these values are the same. You just where the decimal point go. So look at this easy way to look at it now. This number is approximately half, you know, don't it? This is about 0.5 approximately, don't it? And this number is about 24, don't it? Half of 24 is 12. So you're looking for a number near to 12. See that? These numbers are of different magnitude. This one is in the tens, this one is in the 100, this one is in the 1,000, this one is the 10,000. So if I'm saying this number is approximately 0.5, this number is approximately 24, and when I multiply, I get in 12. What's the closest answer to this 12 in the answers? Must be the 11 point something, don't it? That's all. Must be the A, the 11 point something. So this is a nice, easy way to do it. Just do this as being approximately 24 times 0.5, which therefore is approximately 12. So the closest number to 12 in terms of size, magnitude, has to be this one. First one. Has to be this one. There's no way 12 can approximate to this you can talk, you know. Or this one. Or this one. Cannot. So another way to do it is to look at the movement of the decimal point. You can count the decimal point or move, right? Computation really has a lot to do with the position of the decimal point. So let's look at it. Looking how the decimal point changed from this one to this one. What did it do? If it is 235, the decimal point is at the end. It has moved one place back. One place to the left. That's a -1 movement, right? One place to the left to get to this. And then how has it moved from this one to this one? It has moved 2 places to the back, 2 places to the left. That's a -2 places back. So you want to move this one. A total movement is -3. -1 and -2, -3. So therefore the result to get from this answer to down here now, you have to move the decimal place 3 places to the left. 1, 2, 3. So the answer is the one where decimal point is right here. See there? It's another way to look at it. Right? This is 3 places to the left. You have to move it. -3 to get the result of this. So move the decimal point -3, the decimal point ends up here. That's another way to look at it. By counting decimal points. You don't have to waste time working these out, guys. All right. This one now, the distributive law has to do with factorization and expansion. Look at it that way. Has to do with factorization and expansion. So what it is that they have factorized this into one of these. Which one is it? So if I factorize a 49 out of these two terms, I'm going to have the 17 from here plus the 3 from here. So it becomes 49 times 20. 49 times 20, the first one. That's it. Simple as that. So remember, distributive law has to do with expansion. Because I can set a question now where they give it this to expanded. And this is the answer. You get me? I get a question like that. In fact, I know there are questions like that. All right, so one here right away. This one we have to expand. That's it. It's the distributive law again, but it's the reverse. We need to expand this out into one of these. In prep school, they will call this the expanded form for this. So if you notice, the 99 is multiplying throughout. So I'm going to therefore write this firstly as 99 times 100 plus 1. 100 plus 1. That's 101. So it becomes 99 times 100 plus you're expanding 99 times 1. See that? So which one is that? The last one, right? The last one. Don't give it away now, guys. Don't get these things wrong. Too easy. Don't give it away. And so for those of you running away from ADMATS, ADMATS is much easier than CMATS, especially in the multiple choice. But firstly, there are only 45 questions to do in an hour and a half same way. But you can use a calculator in ADMATS, right? And a lot of the questions you can actually work out just with the calculator in ADMATS, believe me. A lot of the questions there are totally numeric. You can just work them out with the calculator. I see a lot of you running from ADMATS and said add. So let me tell you that straight up. ADMATS multiple choice is much easier than CSEC multiple choice. All right, so that is that. Next question. This is a sequence question. So this is basically follow the pattern of the sequence and see what the changes are and apply the next change. That's what it's all about. So here's a +5 to go from this to this. Then here's a +7 to go from this to this. So you see, I added 2 more. Then here's a +9 to go from this to this. So you must pick up the trend now. Got to have a +11, right? To go from this to this. So the next change has to be a +what? 13. Keep adding 2 more than you did before. So the next change has to be a plus 13. So you're adding 13 to this. What you're gonna get? 46, don't it? 46. So the answer is 46. So this one is pretty straightforward. Next question. This thing written as a common fraction. So 0.45. I'll first write it as 45 over 100 and then simplify it down. Become 9 over 20 if I divide the numerator and denominator by 5. So I cancel 5 out of this, I get 9. And cancel 5 out of this, I get 20. But I understand that. But I go to that, right? Let's divide through by 5. So the answer is this one. So it's like a giveaway question. Giveaway question. Next one. All right. So this one says a certain amount of money. I think there's another question like this somewhere in the document. So look, we're gonna see it again. I don't remember where it is, but there's another question like this somewhere else. Didn't get a chance to bring it up here beside it. But a certain amount of money is shared in the ratio 2 to 3 to 9. If the difference between the first and the second share is 40, the difference between the first and the second share is 40, what is the amount of money shared? Huh? So I would say, okay, I'm going to extend the ratio to show the difference. And I want the total as well, right? So look at it now. So it's 2 to 3 to 9. I'm going to extend the ratio to show the difference between the first and the second, and also to show the total. The difference between the first and the second value is 1, don't it? 1. And the total here is how much? 14, that's all? 9 and 5, 14. I want the difference to become an actual of 40. That's what they said. I want the difference to become 40. I want the difference to become 40. So therefore I need to multiply this by 40. So if I want to multiply this by 40 for it to become what it actually is, I have to multiply the total by 40 as well to see what the total is. Simple as that, you know. It's not complicated. So I extend the ratio to show me the difference between the first and the second share. So in the ratio form, the difference between the first and the second share is 1. They could have gotten another question that said the difference between the first and the third share, you know. The difference between the first and the third share, then here will be a 7 this time. And I would do the same thing. Get the 7 up to 40 if the difference was 40. But this time the difference is 1. So I want this one to become 40 to show what it actually is. So I multiply the ratio by 40. So when I multiply by 40, this becomes 40. And it's the total that I want. What does this become? Multiply this by 40, what do I get? This times 40 is how much? This times 40 is how much? 14 times 40. I get 0 first, 4 4 is 16, 4 1 4 1 5. 560. 560. So that is it. The answer is this one. But I understand that? Because I think they like to set the ratio question with these kind of gymnastics on them. You just need to extend the ratio to represent the information that they are talking about. Right? We're going to see another ratio question somewhere in there. I think it spoke about the difference between the largest and the smallest, that one. All right, we're going to see it. I might come back up and look at this one. Well, this one now is pretty straightforward. So this is the difference of 2 squares under the denominator. I recognize this as the difference of 2 squares. So this becomes the square root of the difference first. 17 minus 15 times the sum, 17 plus 15. Then this therefore becomes the square root. This is 2. 50 minus 17 is 2. When you add these two, much I get? 32. 2 times 32 is 64. So you're doing the square root of 64. Which everybody knows that that is 8. Good? That is 8. But then if you know your Pythagorean triple, 8, 15, 17 triangle, you know the answer is 8 as well. You see that? The Pythagorean triple, 8, 15, 17, just like the 3, 4, 5. Right? So if you know the Pythagorean triple, you could recognize this as a Pythagorean triple connecting the 8, the 15, and the 17. 17 is the hypotenuse, right? And they give you the 15. So that's how it will be 8. So the answer is 8. So you see, the more things you know, the better. But if you don't know, you could work it out like this. That's 8, 15, 17 Pythagorean triple. Could have got another question with the 6, 8, 10, or the 3, 4, 5, or the 5, 12, 13. Know that one, right? 5, 12, 13, Pythagorean triple. Yeah, so you can look out for those. 5, 12, 13. In other words, I could have give you one where it is 13 squared minus 5 squared. Not 12 squared, 13 squared. Minus 5 squared. And that's how it be 12. How is it 12? Because it's 13 minus 5 times 13 plus 5. What is work out? 30 minus 5 is how much? 5, 12, 13. 30, I use 12. That's a simple answer. You'll more than likely give it 12. 12. 12. So it will be the square root of 1 plus 1 times 25, which then will become square root of 25, which will be 5. Right? So this will be 5. They gave us that. All right. This was one, remember, guys, you're not squaring these. And you can easily change this question and put minus 3 cubed plus negative 2 cubed. So you have to look out for stuff like that. Instead of squared, I can change those to cubed. All right? But this one becomes the negative 3 squared is just 9. This one becomes a positive 9. This one becomes a positive 4. When we square a negative number, it stays positive. So the answer is 13, right? This is the answer. But I'm saying to you, they could have given you a situation where you have negative 3 cubed plus negative 2 cubed. Remember, when you calculate the cube of a number, I could put the cube on one of them. So you can change and put the cube on just one of them, for example. Maybe let this one stay as a square and put a cube on this one, for example. Change that to a cube. This will become negative 27. Wait, no, lie. That's a square one, so it become 9. Negative 2 squared will become, negative 3 squared will become 9. But this will become a negative 8. And the answer for this one will be 1. So you can look out for a change like this, guys, a simple change like this, and the answer will be 1. Or if I cube both of them, negative 3 cubed and negative 2 cubed. This will become negative 27. 3 times 3 times 3 is 27. Because you're cubing it, the value stays negative. When you raise a number to an odd power, the sign stays the same. So, for example, if you raise a negative number to an odd power, it comes negative. Comes what? Negative. If you use a positive number to an odd number, it's going to come back positive anyway. So this will be negative 27, and this will be negative 8. This will be negative 8. So that's what you'll be working out. Negative 27, negative 8. What that work out to? 27 and 8 is how much? 35. Negative 35. That will be that one. All right, so look out for stuff like this. Next question says, what number when added to 1 1/3 becomes 2? So if you have 1 1/3 and you want to reach 2, you have to add another 2/3, right? But I get that? So this one is pretty straightforward. You have to add 2/3. If you have 1 1/3, you have 1 1/3. And you want to reach 2, you have to add another 2/3. Right? 1 plus 1/3 plus another 2/3. Because it's 1 1/3, it's the same as this, you know. It's the same as 1 plus 1/3, you know. This 1 1/3 is the same as that. Same as 1 plus 1/3. So 1/3, you need 2/3 more to make another whole, to make the overall value become 2. Right? So it's a 2/3 that you need to add. Some simple things easy, simple things more difficult to explain, you know, because them so easy. All right, this one. So they give you this to divide by, right? What I would do is turn this into a fraction and then invert and multiply. So I would have 11.1 divided by, turn this into a fraction, which is 1 over 100. And then I invert and multiply. So it becomes 11.1 times 100 over 1, which is really times the 100. So you move the decimal point 2 places to the right, 1, 2. So it becomes this answer down here. So it has 3 ones in it. You won't give it away and mark this one, you know. This one, you know. Don't give it away. Yeah? Huh? Who decimal place what? This one? If you recognize I move decimal place to the right, I don't have a problem. If you know when you divide by, so what if this was a multiply? Instead of a divide, what do I do? Huh? Move it to the other side, the other direction. All right. Well, if you understand that if you divide by a number like this, you're moving to the right, fine. Once if you understand that, no problem. But I'm showing it, make it more glaring by doing this calculation. It's more glaring that way. You get me? All right. And this is basically the same question, you know. This is the same question. Just like the 2, 2, 2. So it's really the same question. So for this one, if you use the same approach, it should be 22.2 divided by, I put this now as 2 over 100. And I invert and multiply. 22.2 times 100 over 2. So this 200 here cancels down the 2's here and turn this into 1.1. And then it becomes this answer again. Well, decimal point 2 places to the right. Becomes 1110. All right, so basically that's the same question from 2 different papers set that way. I'll look at this question now. 12.5% of a sum is 40. 12.5% of a sum is 40. What is the sum? Some people say, I have to calculate this out. You don't have to calculate this out. You can do this as a ratio again. The sum is 100%. So you want to build that 40 up to 100%. So look at it this way. 12.5%. Look at it this way. I'm going to do it like this. 12.5% is $40. The whole amount is 100%. So I want this to become 100. That's 12.5. Now I count up to 25 first. Easy numbers. So multiply by 2 first. If you see you can multiply by 8, no problem. But I multiply by 2 first. Multiply by 2 first, I get 25%. So if 12% is 40, then 25% is 80. If 25% is 80, 4 times 25 make 100, don't it? Therefore, multiply by 4 now, you get 100%. So therefore, 100%. Therefore, 100% multiplied by 4 is, this times 4 is how much? 32. 320. So the answer there, 320. So you have to do mathematics one way where you can't use a calculator in the multiple choice. So 12% is 40, 12.5% is 40. You want to know what the whole number is? You build up that 12.5% until you reach 100. Build it up step by step. But you can't use a calculator. You don't have to be manipulating these numbers. Multiply by, I work with 12.5% and all these things. The 12.5 is half of 25%. We count up to 25% first. If 12.5 is 40, then 25% is 80. And then from 25% to reach 100, multiply by 4. 100% is 320. So the whole is 100%. So the whole number is 320. But understand that? All right. So if we get other values, you know, you can use this kind of approach. All right. Next question. A test was marked out of 80. A boy scored 60% of the marks on the test. How many marks did he score 60%? So this one kind of easy. You're going to be multiplying 6 times 8. So the answer that has 48 in it is the answer. Materially, in terms of the values, you're going to be multiplying a value of 6 by a value of 8. 6, 8 is 48. So the answer with the 48 in it is the answer. That's the only answer with 48 in it. So the answer has to be 48. Right? But if you want to work it out, you work it out 60% of 80. So it is 60%, 60 over 100 times 80 you're working out. All them zeros here just cancel out each other now. And you will multiply 6 times 8. So it has to be 48. You don't have to waste time. 48. All right, this is another repeat question, but I see this question set other ways already as well. With this 60% of 40 students and girls and so on. I see this question set other ways already. But this one says 40, it says there are 40 students in a class. Girls make up 60% of the class. 25% of the girls wear glasses. How many wear glasses? Now I've seen a question where they ask how many don't wear glasses. So be careful. So you want to say how many wear glasses? You can look out for them, say how many don't wear glasses. Look out for that. So you look at how many wear glasses. This is 25% of the girls, right? So you can set up like this. 25 over 100 of the girls we want. What is the girls? The girls represent 60% of 40. So it's 25% of 60% of 40. That is the girls, 60% of 40. So that's what you're working out, you know. That's what you're working out. So just cancel that down and you get it. Step by step. This going to give me 24. Going to give me 0.24 times 25. Looks like a 0.8. Quarter of 25. 24. Looks like 8. Quarter of 20. Because this is a quarter. Quarter of 24. This is going to give me 24. Can't see it down. So it looks like an 8. This looks like 8 is the answer. This 25% is a quarter. This is 24. 6 times 4 is 24. Right? And this 25% is a quarter. So, done all right. Huh? Quarter. Oh, it's a quarter. Quarter of 24. Quarter is 6. Yeah, quarter of 24 is 6. Not 8. Quarter. A third of 24 is 8. Third is a quarter. We can work it down still. This can be 24. Because these zeros will cancel. All right. So it's actually 6, my mistake. Quarter, not a third. So it represents a quarter, right? 25% is a quarter times, and this works out to be 24. Yeah, so it's a 6, 1 6. My brain was thinking a third. So that's 6. All right, that is that. So remember, now, look out for them, say how many girls don't wear glasses, you know? And that answer would be what? 34, right? Them say how many don't wear glasses. Now it will be 34, you know. It will be of the girls. It will be of the girls. So it will be 18. They ask how many girls don't wear glasses, it will be 18. Because there are 24 girls. So careful. All right, that is that. So a question here, they make a minor change. So I have 2/3 squared and I have 2/3 to the -2. Small change, different answer. All right. So this one, you basically just squaring the 2 and squaring the 3. Because like this one is like 2/3 times 2/3, you know. That's what it is, you know. It's like thirds times 2/3. That's what the square means. So it becomes 2 times 2, 3 times 3. It becomes 4/9. This is the answer. What is negative 2 on here now means reciprocal. The negative 2 means that you're taking the reciprocal of this. So this one is the same now as 3 over 2 squared. The negative on the power means reciprocal. So you take the reciprocal of 2/3. The negative power means reciprocal. So you're really doing 3 over 2 squared, which then becomes 9 over 4. So the answer for this one is 9 over 4, this one. But if you notice, this answer is also there. So if you see this question, if you know this question and you see this one and think it's the same, you might put 4 over 9. So it's wrong. But the 4 over 9 answer is also there. So that's why you have to be careful and look. Don't assume it's the same answer, right? All right, next one. They want us to write this correct to 3 decimal places. These are 3 decimal places using this 6 to correct that one. So this one kind of easy. Increase that by 1. So you get 314. 3141. 3141. So the answer is this one. That one kind of easy and straightforward. See this question repeat. It's a repeat question. The answer was this one with the square, right? I would know it's for sure it's the same question. Standard notation. So we did this question earlier. All right. So the question here again that I told you about is a repeat question. It says 560 is shared in ratio 2 to 3 to 9, right? Let's see how they set the question up here before. We did it earlier. Where is it? See it here? So the same question, you know. 2 to 3 to 9. And amount of money shared in ratio 2 to 3 to 9. And the answer was 560, right? The difference between the first and the second share is 40. Right? Same question, and look at it down here, so now. Look at it down here, so now. Now they give it the total, 560. Same ratio, 2 to 3 to 9. The difference between, now they said the difference between the largest and the smallest share is, so they're asking for now the difference between the largest and the smallest share. So you see, it's the same information. So how do you set up this one? I would say, okay, 2 to 3 to 9, and the total is 14. Total is 14, representing this. And the difference between the largest and the smallest share is 7. So I'm adding these, I'm extending the ratio to include those. I'm writing them out in blue. So I would extend the ratio to include the total and the difference that they're talking about. The total of this ratio is 14. The difference between the largest and the smallest in this ratio is 7. And they want us to tell them the difference between the largest and the smallest. So when I extend this to the actuals, I'll get the answer. So I need to extend this 14 up to 560. What do I multiply this by for it to become 560? What do I multiply 14 by for it to become 560? It's 40. You don't know, you can go step by step, you know. Just build it up step by step, but it's 40. Right? So for this to become 560, I multiply by 40. I multiply this ratio by 40 is a different color. Yeah, times 40 is a different color. You multiply this by 40 for it to become 560. You have to multiply it by 40. If you don't know, you just build it up step by step. Build up the 14 step by step. Multiply by 2, 1, and multiply it up until you reach 540, but until you reach 560. So when the total reach 560, where does this reach? I multiply it by 40 as well. It becomes 280. So the answer is 280. Understand that, guys? All right? So extend the ratio, represent the information that they give you, and multiply it up to what you want. Simple as that. So another one down here. If 350 is shared in ratio 2 to 5, Then the smaller share is, well, the total parts on that is 7, right? And the smaller share is a 2. So the answer is just 2/7. 2/7 times the total. This one kind of straightforward. What I work out to? 100. 7 to this goes 5 times, don't it? And 2 times 5 is 2 times 5 is 100. This is the answer. And we can just double check it. 2 to 5 to 7. This to become 35. I multiply by 50. Yes, I multiply this by 50. Becomes 250. Multiply this by 50. Becomes 100. So they add to 350. 350. And so smallest share is 100. All right, next question. Here's another question that I said similar, different ways on different papers. So 60% of a number is 90. What is 4/5 of that number? You don't have to work out the actual number. You know? You can say, okay, the 60% really is 60/100, right? Times a number, let's call that number n, is 4/5. Oh, the one 4/5 is 90, sorry, is 90. We want over here to become 4/5 of n. That's what it is now. So you work it down. This over here is the same as 3/5. Because you divide this by 20, you get 3. Divide this by 20, you get 5. So this is 3/5 right now. So we can say, okay, 3/5 times the number is 90. I want over here to become 4/5. So for it to become 4/5, I'm going to divide by 3 and divide this side by 3 as well to get rid of this 3. And then multiply by 4 and multiply by 4 as well over there. So this side becomes 4/5 because the 3 cancels the 3. So this side becomes 4/5 of the number. Whatever this work out to know is the answer. That is 120. 90 divided by 3 is 30 times 4 is 120. So see there, answer is 120. But to go to that, you have to work out the actual number. If you want to work out the actual number by taking the 60% and then multiply by 4/5, no problem. But I think this is a good enough way to do it. Huh? Do it that way. So 60%. Oh, well, it's 60% of a number. You know. We can't take 60% of the 90. You know. It's 60% of a number is 90. 60% of a number is 90. So if you want to know what the number is, you can say, okay, you can do the 100% thing again, or we can just divide. If 60% is 90, that's 3/5 times the number is 90. They cross multiply. The number becomes 90 times 5/3. All right? 3 into this goes 30. 3/5 is 50. So the number is 150. Number is 150. So that to know that the number is 150, you want to calculate 4/5 of 150. So you can say, therefore, 4/5 times 150. That's what you're working out. See that? So you do 5 into this, you get 30. 4 times 30 is 120. So this way, you're going to get the 120 just the same. So that's the other way it could be done. Don't it? Put in a different color. I'm right over in different color. Right, so the other method, I can put it right here. The other method is to say, okay, since 60% of a number is 90, the 60% is 3/5. of a number is 90. So the number becomes 90 times 5 over 3. So multiply the 5 and divide by the 3. If you write this out, you're gonna get 150. Because 3 into this goes 30, right? 30 times 5 is 150. So you're gonna get the number as 150. Therefore, 4/5 of 150 is what you want. Right? Which becomes 120. 120. The answer is 120 if you do it that way. So this is our method. Over here, it's a similar question here. Same thing I ask with different values. 30% of a number is 45. What is 4/5 of the number? Similar kind of question. So we could say again, would say 30%, 30 over 100 times a number equals 45. And I want this side again to become 4/5. What is this? This is 3 over 10 right now, 3/10. This is 3 over 10 times the number equals 45. So I can work on the number and then the 4/5. But I can break this into 2 times 5. I'm sure you can do it skillfully. Break this 10 into 2 times 5, right? And I want to leave the 5 here. So I want to get rid of this 3 and get rid of that 2. And I want a 4 there now. So I'm going to come, so now I'm going to multiply by a 4. I multiply by this by a 4 as well. And I want to leave these. I want to leave this and this. Because I want to leave those 2, I have to get rid of this 2. So I'm multiply this 2 and leave the 4/5 times n equals 45 times 4. Multiply by this 2 up here. And divide by this 3 under here. And you're working that out. Understand that transposition? Understand that? Read it again. It's basically playing around with the numbers because you can't use a calculator, right? So here's what they said. They said 30% of a number is 45. So you set it up like that. 30% of a number is 45. So again, remember, you can do it by finding the number. So you can find the number. So you can cancel down this, divide down the 3, so you get 15. You can find the number that way, right? So you could reduce it and say, okay, let's do that way. We'll find the number first. You could say, okay, 3/10 of the number equals 45. So you're going to get the number equals 45 times 10 divided by 3. So that, right? So multiply up the 10 and divide another 3. So this means that the number is 150. So the number is 150. So the same calculation, you want 4/5 of 150 now. So maybe this is the easier way to do it. So come back for the red now. You can say, therefore, 4/5 of 150 is the same 120. Because 5 into this was 3. 4 3 is 20. So it's the same 120. So it's the same answer. 120. That is it. So it's really the same question, but use different values. Here's another question where you can look at the values and know the answer. This, again, we can say, all right, it's almost 0.5. Of that is almost 20. So you can say, okay, the value is that near 0.5 times 20. Because these numbers are different magnitude in terms of the tens. Right? 40. So looking at a number near 20. So the closest number to 20. In terms of the value, the size of the values. So the answer must be this one. Just looking at it, the answer must be this one. It has to be this one based on the size of the numbers that you're working. But then you could work decimal places again. Move decimal point, right? So look at it. How do I go from this to this? I move decimal place one place to the right, one place to the right. That's a +1 move. Then from this to this, there's no change. There's no change. So the answer is to move decimal place one place to the right. See there, one place to the right. That's the answer. One place to the right. That's the answer right there. If I move decimal place one place to the right on that, that's because there's no change in this one. Only this one changed. This one changed to that. So like you multiply by 10. Right, that's one straightforward. So the same numbers here again, but this time we change some of the values, right? They change the decimal places. So if you look at it, it's the same values again, you know. So again, I can look at this and say this is about a half of 370. So we get 150 something, 100 and something. Half of 370 is 1 something. So it must be this one. That's the answer, you know? Without working it out. Just the size of the values you're using. Right? That's the answer. But if you want to look at the decimal place where the points move again, from this one to this one, you move one place to the left. So -1. From this one to this one, you move 4 places to the right. 3 places to the right. You go from this to this, and you move 3 places to the right. 1, 2, 3. That's a +3. So the net move is +2. 2 minus 1, +2. So you move decimal place 2 places to the right. 1, 2. +2 is the result move. So the answer is where decimal point is right here. That's why this is the answer right here. But as I said, you could look at these numbers and just use an estimation method to see what it is, because this magnitude of numbers increasing by 10. Right? This is 10 times this, 10 times that, 10 times that. So it's easy. Any number that is within the same tens. This one is in the hundreds. The answer must be in the hundreds based on this. Must be in the hundreds. It's about a half of that. Must be in the hundreds. So that is the answer. So not everything has to be worked out, guys. This one again. Total of 540 be the sharing ratio. 4 to 5. What is the larger share? The larger share is 5 out of the 9, right? 5 out of the 9. So it's 5 out of the 9 times the total beads of 540. But I work out to. You can't use a calculator, you can't use it. That's what you're working on, 300. All right, 5 out of the 9. Total share is 9 parts. The larger part is 5 out of the 9. It's 300. This into this is what? 6 times. 6, 5, 30, 300. They cancel it down. If you cancel it down, this into this is 6 times. So you get 60. 5 times 60 is 300. All right, that finishes that one. Well, more of this. All right, this one says the first 3 common multiples of 3, 4, and 6. This one you can almost use elimination. First 3 common multiples. Common multiple. You can use elimination. Can't be this one. Those are factors. Common multiple. Well, 4 is not a common multiple of 3. So this can't be the answer, right? This can't be the answers. You want a common multiple. So this one is not it either. This one, 8 is not a multiple of the 3. So it can't be that one either. 8 is not a multiple of 3. That one out of it. So the answer must be, the one left is the last one. This must be the answer. I can check it. 12 is a multiple of these 3 numbers. 24 is a multiple of the same 3 numbers. 36 is a multiple of the same 3 numbers. That's it. All right. Here's a repeat question. Dan sold 40 tickets. I said, change it on 2 different papers. Look out for this one and change it again. And it's a very recent question, like in the past 2 years. Let's set this question. Dan sold 40 tickets in 5 days. Each day he sold 3 tickets more than the previous day. The number of tickets sold on the third day is, and I've said the same thing information. Dan sold 40 tickets in 5 days. Each day he sold 3 tickets more than the previous day. When the ratio of the what is the ratio of the number of tickets sold on the third to the number of tickets sold on the 5th day? So the same information, you know, but they're asking something different. So look out again for the same question, they're asking something different. So I think the method, a good method to solve this question, let me put it over here. He says, okay, he sold a total of 40 tickets, right? So when I say day 1 he sold X tickets, day 2 he sold X plus 3. Next day he sold X plus 3 days more, X plus 6. Then the next day he sold X plus 9. How many days? 5 days. Next day he sold X plus 12. That's the total number of tickets that he sold. I build it up like that to work it out. This is 5X plus. What is that up to now? What is that up to? This is 9 and 9, 18. 18 and 12 is how much? 30. This is 30. And that equals 40 tickets. So based on that, X equals how much? X equals 2, right? Let's subtract the 30 first, you get 10 and divide by 5. So X equals 2. So now that you know that X is equal to 2, we can actually write down the tickets that he sold. He sold 2, then 5, then 8, then 3 more, like 11, then 3 more, like 14. Those are the tickets that he sold. These are the actual tickets that he sold. So this answer asking for the tickets sold on the third day. That answer is this one, third day. So the third day question is answer is 8. For this question, asking about ratio. What is the ratio of the number of tickets sold on the third day to the number of tickets sold on the 5th day? So here now is the 5th day total. All right, this is the 5th day. So the third day ratio to the 5th day ratio is 8 to 14, which reduces to 4 to 7. 8 to 14 becomes 4 to 7. So the answer is 4 to 7. So if I set a question like this again, guys, I might just set it again and ask something different. I think this is the only 2 times I set this question, you know. To my recollection, I think it's only 2 times I set this question. And it's 2 different ways I set it with the same information. But that's how I would do it. All right, next one down here. Square root. The square root of 181 lies between which 2 numbers? So what we know is that 13 squared is 169 and 14 squared is 196. 181 is between them. So the square root of 181 must be between those 2 numbers. These are 2 consecutive numbers. And 181 lies somewhere in between here. 181 is between them, right? Somewhere in between. So therefore, the square root must also lie between 13 and 14. Make sense? That's the same question here, but I put 191. So the result is the same approach. So I can literally just copy this down. I can literally just copy this down. Same approach and change this to 191. 191 is still between 180, 169 and 196. These are two consecutive squared numbers, 169 and 196, because the result from 13 squared and 14 squared. So there are two consecutive squared numbers. Right? So the number between them, 191 is between them. So that is that. So the answer is 13 and 14 here. All right. I think we're done the first part. We'll take a short break now. Stretch your legs and come back. How long are we going so far? Huh? No, we started after, we started 11 o'clock. I'm going to take a 10 minutes break now. 10 minutes. No, 10 minutes break. 10 minutes break. Don't need no more than that. 10 minutes break. All right, online, can you hear me again? Can you see the screen? I'll double check in. Hello?
Yeah, man, sir, where are you?
All right. All right, so we're gonna run through some sets questions now. We're gonna finish off with sets today. As you know, tomorrow we're coming back to 2 other topics, right? Consumer arithmetic and something else. I don't remember what it is yet. All right, so let's just run through some of these sets questions and look at some of the similarities and differences between them. All right, let's go. So this question basically is almost the same. Two of them, the one here, well, the one here, and the one in the box. This one says the following statements describe the set of integers greater than 0.3 but less than 6. That's between 0.3, not 0.3, negative 3. You want values greater, so you want x to be greater than negative 3. At the same time, you want x to be less than 6. You can break it this way. Negative 3 is less than x. Huh? Yeah, one charge? Yeah. Oh, yeah, man, you can plug it in. You can plug it in over this one. But at the same time, x is less than 6. It's a less than situation. All right? So the x is between. So this is the answer down here. All right? That is that. So look at this one now. See similarity. It said, which of the following statements describe the set of integers from? But this word from means now that you're including them. That's a difference, yeah, man. All right, cool. This word from now means that you're including the values. So you include same negative 3 and 6 now. We're now including them. So you're between them still, but you're now including them. So it has to be this one now. Because the equal is on these. Look at the difference, you know. Over here, you're not including them because over here, you're not including them. Sorry. So it's a less than. Over here, it's basically the same range, except that you're now including the values. And this Z is a symbol for integers, yeah, guys? Z is the set notation for integers, positive or negative whole numbers, Z. All right, so that is the answer for that one. The word from means that you're including them from negative 3 to 3. This one could have also been between. They could have also said, they could have written this same wording here. Instead of put the word from, they could have said between. So if they had said between, so this is for the from. If they had said between, this one would be for between. So if they give it the same wording and change this word to between, then this will be the answer. Simple as that. You just say between. All right? So be careful. Be careful. All right. This one says, which of the following set is defined by this? Now, if you notice, you're including the negative 2 because of the equal here. You're also including the 4, again, because of the equal. So you're from negative 2 to 4, inclusive. So it has to be this one, including everything. All right, so it has to be this one. By including everything. All right, all the values, all the positive or negative whole numbers from negative 2 to 4, inclusive. All right. This one down here says, it refers to the Venn diagram, which shows 2 intersecting sets, P and Q. The number in P is 5, number of Q is 9, number in the union is 10. Now, there's a nice little sets equation that is good to know. You're going to see a lot of questions where this is applicable. And let me write it out here for you. So for any 2 sets, I'm just going to use A and B for this example. For any 2 finite sets, they have to be finite sets. The number of elements in set A plus the number of elements in set B will always be equal to the number in the union plus the number in the intersection. The number in the union, A union B, plus the number in the intersection. A intersect B. A lot of the questions you'll find, this becomes applicable. So it's quite simple. The total of these two must equal the total of that two at all times. All right, so any three of them they give you, you can find the third one, the fourth one. So here they're giving us the number in P and the number in Q. Is that they give us these two over here now? So these two add up to 9, add up to 14 right now. These two add up to 14. So this one and the one that they don't give you, this one and the one that they don't give us, which is the intersection. The shaded region really is the intersection now. The shaded region here is the intersection inside here. Is the intersection. It is really P intersect Q. So them two here must add up to 14 as well. So since these two add up to 14, these two must also add up to 14. So if this one is 10, this has to be 4. Since this one is 10, this one has to be 4. So the number in the intersection is 4. But that's not simple as that. So the answer here is 4. All right, that's it. All right, you're going to see a lot of questions where we apply this. A lot of questions we're going to apply that. So we're going to literally fly through those. All right, look at this one now. So this is what I set it on one paper. They give the same information. And one exam paper they ask for this. Another exam paper they ask for this. From the same information. So this one now is the intersection of the three sets. P intersect Q intersect S. That's what this is. What value is in all three sets? The 2 is in all three sets. 2 is the only value in all three sets. So this answer is 2. So the answer is this one. This is a different question now. They want Q union S, and you're doing the intersection with P. So basically I have to set that up. So firstly, we know we have P. Let's work it out step by step. We know P is a set 2, 3, 5, 7. And then we need Q union S. We need Q union S. We're going to work out what that is. And then work out the intersection between them. So Q union S now is these two. Remember, I can't repeat any of the values. So we have 2 there. Then we have 3. Then we have 4. Then we have 5. Then we have 6. This is the union of Q and S now. And then we're looking for the intersection between those now. This means that we want the intersection between the P and this. We want the intersection of those two sets now. What are the values in the intersection? 2, 3, 5, 2, 3, and 5. So the answer is 2, 3, 5, which is right here. So this is one that you basically have to build up. You have to work upon it. So again, they can come with another question with the same 3 sets, guys, and ask for a different setup. Just note that if you can't work it, if you can't look at it and know what it is, you can set it up like this by pulling out the individual sets and build it up gradually to get what the answer is. All right, but that is it. 2, 3, and 5. All right, that is that. All right, next question. Give us those 2 diagrams. This question and this question is the same, you know. Just that over here, they gave this region shaded. Over here, they ask us for it. It is still referring to the intersection there. So the answer is the same. It's the same 5. See there, the same 5. Number in P is 5. Number in Q is 9. Number in the union is 10. The same question. And they're asking us for the intersection. So the same solution as over there. So I'm going to put that thing across and put the word same. Same. So the answer is still 4. Remember, these two add up to 14. So these two must also add up to 14. This is 10, this going to have to be 4. That is it. Similar question down here again. The number in the unit is 25. Number in A is 14. Number in B is 15. The number in the unit is 23. What is the intersection? The same thing again. If these two add up to 29, then these two must also add up to 29. If this is 23, then this have to be 6. I'm going to add up to 29. Simple like that. So this has to be 6. Because this is 23. 23 and 6 make 29. So this one, the number in this one has to be 6. This is the answer. But I get that? Simple. All right? Simple as that. Let's continue. This one gives us this information. P are prime numbers, Q are odd numbers, R are even numbers. Which of the following set is empty? No odd and even number is the same. No odd and even number is the same. So this will be an empty set. Right? None of them is the same. No odd number is the same. So this will be disjoint set. What we call disjoint. They'll be in 2 separate sets. And so the one that will be empty is the intersection between odd numbers and even numbers. There's no odd number that is odd. So it's Q intersect R. Q intersect R, this. This jump. If we do a set diagram for these, Q and R will be 2 separate sets. You have odd numbers over here. You have even numbers over here. So there's no intersection. Intersection is 0. They are mutually exclusive. Disjoint sets. All right, that is it. Next one says, A is that set, B is that set. Which of the following statement is true? Let's examine it. They're asking us about some subset. If the intersection is empty, if they are disjoint, if B is a complement of A. Let's see. So firstly, I can say that you have 6 here, 6 here. Anybody have a key here? Maybe somebody at the bathroom. I think some girls down there. And we have 9 here, 9 here, 12, and 12. So B is a subset of A. B is a subset of A. So the answer is the first one. This means B is a subset of A. So this is the answer. Don't go no further. Because B is a subset of A. All right? Because all of B is inside of C. So B is a subset of A. Next one says, if the universal set is this and H is that, what is H complement? H complement is everything that is not in H. So if I identify everything that is in H first, so 3, 3, 4, 4, 6, 6. Those are the values in H. So it means that these 3 values are in the complement. 1, 2, and 5 are in the complement. So H complement will be 1, 2, and 5. The values that are in the universal set, but not in H. So that is it. So the answer is this one, 1, 2, and 5. This complement means what is not in H. All right, that finishes that. Going good so far. I think we can finish relatively early today. This one says the elements of a set. Look at this now. Let me rewrite this for you so you can see it. This is a 6. And put it in red. And put it in red. So this is 6 less than or equal So x less than 10. X is such that, all right, where x is an integer. So x is a member of the set of integers. That's what this is. And that is your set. So you're between 6 and 10, including the 6, but not including the 10. And you're an integer, meaning you're a positive or negative whole number. So which of these is the answer? You have to include the 6, but don't include the 10. And don't miss out any value. So it looks like this one. 6, 7, 8, and 9. That's the answer. You have to include the 6, don't include the 10, and you're an integer, meaning you're a whole number. Positive or negative whole number. So 6, 7, 8, and 9. That is the answer right there. That is the set. All right. 6, 7, 8, and 9. Cannot include the 10. All right, that is that. This one says this refer to P is P, M is PQR, N is PQ. Which of the following statement is true? This is saying M is a subset of M, of N. This is not true because M actually is bigger than N, so that can't be true. So this one is not true. Let's use a process of elimination. This one is not true. Is this one true? M intersect N equals N. Now, first, what is M intersect N? Let's write it out. M intersect N would be the set of P and Q. See me? And P and Q actually is a set N. So this one is true. That one is true. This one is not true because the union would include R. So this one is not true. And this is saying the intersection is an empty set. This one also is not true because the intersection is actually PQ. So this one is the correct answer. That one is true. Process of elimination. All right. That finishes that. He said, which of the following pairs is an example of disjoint set? So this question really is the same question up here now that they gave us, you know, written a different way, including the odd and the even. It relates to that one. Disjoint set is a set of odd numbers and even numbers. All right, even and odd numbers are disjoint sets. What are disjoint sets is, as I showed before, sets that have no intersection, two separate subsets. Disjoint sets. So E will be the even numbers, F will be odd numbers, and they are disjoint. So the answer is this one. Even and odd numbers. Multiples of 2 and multiples of 3. This one example is the number 6, so that can't be true. That's not disjoint. Whole numbers and rational numbers. Every whole number is a rational number. Because a rational number is one that can be expressed as a fraction. So for example, 2 is the same as 2 over 1. It is whole and it is rational. A rational number is a number that can be written as a fraction with a whole number numerator and denominator, except when the denominator is 0. So that one is not true. Multiple of 5 and 10. Multiple of 5 and 10 is actually like about value like 20. So 20 will be in the intersection of multiple of 5 and 10 as an example, right? Even 10 itself will be in the intersection. So that is that. So this is what this joint set would look like. This joint sets look like that. This joint. All right. It says all students in a class play Scrabble, or checkers, or both. 36%. So once I get into percentage, guys, you know that the total percentage is 100, right? Everything must add up to 100. So if we were to sketch it out, quickly, and say there's an intersection because they say or both. I want to put S for Scrabble, C for checkers, U for you. And they say all. So it means that there are nobody out here, right? Or this is empty, all. Let's put in the values now, the percentage. So representing the set with percentage. If 36 plays Scrabble only, so they put in 36 right here. So. And its percentage. 16 play both. So 16 inside here. Play both. 16 play both. What percentage play checkers but not Scrabble? Here's what I'm asking you for. This must complete the 100%. So if this is if the value right here says X, you know, so 36 plus 16 plus X must equal 100. What does it work out to? This work out to what? 52. This is 52 plus X equals 100. So X is 48. So the answer is 48% right here. I think there's another question like this on the paper in somewhere. Scrabble is antique. Where is it? Scrabble. All right, if I find it, I'll come back up there. See it here? Another one here. Can do this right now. All students in a class play Scrabble or checkers or both. 36, see, it's the same question now, but the change of values. 36% play Scrabble only, 48% play checkers only. What percentage play both? 16 that they miss out on the next question. Right? So the same question, but it actually change up some of the values. So I tell you guys, you cannot go assume that it's the same question. I must copy this down. Same information, basically, or the question related to the same information, but they reverse some of the data. Some of the info is reversed or switched around. So this is it. So this time, what they give us these. So this time they said the 36% is Scrabble only. That's the 36 right here. And 48% play checkers only. We need 48 right here. And this time they ask us what percentage play both. That's the X inside there you want now. That becomes a 16 this time. Because you know, again, that 36 plus X plus 48, that must equal 100. This and this add up too much. X plus, much is that? 82, 84 equals 100. So subtract that, you get the X equals 16. The answer is 16%. All right, that is that. Let me go back up here. All right, over here now. More repeat question. This question says, item 11 refer to the Venn diagram showing two intersecting sets. The number of students in each set is indicated. All right. So it says in the Venn diagram, U are those who play games, H is for those who play hockey, V are the students who play volleyball. How many students play either hockey or volleyball, but not both? So you don't want to include these, not both. So you don't want these. Play hockey or volleyball, but not both. So that's 9 people. So the answer for this one is 5 plus 4 is 9. 5 plus 4 is 9. And then this question now was presented with the same Venn diagram and asked a different way. Same Venn diagram, same information, right? And a different exam paper. Said the number of students in each set is indicated. How many students play exactly one game? The same answer now. One game. Them not play none, so you can't include them. So the answer is the same, 5 plus 9. Play exactly one game. So it's a different question to ask, but the answer is the same. I said, I have the same 4 answers. All right, so this one is the same. So again, it says 5 plus 4, which is equal to this 9. All right, so sometimes they change the wording of the question, but the same answer, same question. So same thing they're asking in a different way. This one says, the set of 2-digit positive integers that is divisible by 7 is an example of improper set, infinite set, empty set, finite set. What's an infinite set? The infinite set, an infinite set is one that never ends. Go on and on and on forever. Like if I said the multiples of 2. Multiples of 2 go on and on and on and on forever and ever. Amen. That's an infinite set. There's no ending. A finite set is one that terminates, is one that has a set number of values in it. A finite set. It has a number of values in it. What's an empty set? Everybody know what an empty set is. An empty set is one with no value, empty, no member, no element in it. What's an improper set? Now, the word improper set really, and I'm going to tell you what it is just in case they ask a question about that becomes relevant. So improper set has to do with subsets. Now, subsets can be proper or improper. I'll give an example what I mean. So I'm going to write that out over here for you. Show you for the term improper. So let's talk about subsets. I'm going to do a little example. Let me do it in purple. Subsets. So let's say we're working out the subsets of the set A, B, C with 3 values. So a set of 3 values will have 2 cube number of subsets. So the number of subsets will be equal to 2 to the n power. Since it has 3 values in it, it becomes 2 cubed, which is 8. So we have to get 8 subsets from that set of 3 values. 2 to the n, you have to remember this, guys. 2 to the n power is the number of subsets. All right, so what will be the subsets now if we were to list them out? First, you would have the sets with just 1 value in it, right? So you have A, you'd have B, you'd have C. Then you would have the subset with 2 of the 3 values in it. So you have AB, you have AC, and you have BC. And people believe that you'll be finished right there. But the fact of the matter is that the empty set is a subset as well. And the whole set, ABC, is also a subset. And this is where the word improper comes in now. These subsets, which are like parts of the whole set, are called proper subsets. So we get a question about this, you'll know. Proper subsets. Subsets. And so these two, the null set and the full set, they are called improper subsets. So that's where the word improper comes from, relating to sets. In case I ask a question with this, that becomes relevant. So this you would know. So the null set and the whole set form the improper subsets. So the improper subsets will always be only 2 sets. The improper subsets, no matter how many sets you have, no matter how many elements a set has, the improper subset is always 2 sets alone, the empty set and the full set. Only 2 of them there. So the improper subset will always be just 2 sets alone. You see here, for example, these with the single values is one value, one element each, and then these is two elements each. If you had a set with more than those three values, then some of your subset might have three values and so on, right? The improper subsets will always only be two of them, the empty one and the full one. Good? So they ask a question like that, how many improper subsets are there in a set? Two. Two, must be two. Full set and the empty set. All right, if you ask a question like that. All right, so that's it. So for this question now, the number that are divisible by 7 are multiples of 7. So really looking for multiples of 7. And you want the 2-digit ones. So this question is referring to the set like this. This question is referring to the set 2-digit multiples. So the first 2-digit multiple of 7 is 14, 14, then 21, then 28, and then which one next one? And go all the way up to the one that comes just before 100, which is 98. 98 is the last one. That's a finite set, 2-digit values that are multiples of 7. That's a finite set. So the answer for this is a finite set. This one now, the set of positive integers that are divisible by 6 is an example. That's an infinite set. Because this is now is asking you for multiples. It's divisible by 6. And instead of putting a 6 here, put a 7 here now. And if you put a 7 here, you might think it's the same question. But a different question actually. Of 6. That's what this is. Multiples, multiples, multiples of 6. So multiple of 6 is a non-ending set. There's no set. There's no number of multiples that go on and on forever and never end. So that's an infinite set. So the answer for this one will be an infinite set. Because multiple of 6 would start from 6, then 12, then 18, and go on and on like that. That's why you normally write an infinite set. You end it with these 3 little dots, meaning that it go on and on forever. To infinity. That's an infinite set. So I say infinite goes on to infinity. Infinite. All right, that is that one. All right, so far so good? Body good? All right, down here. To give this diagram, it says it refers to universal set U, and 2 sets T and C represent the students who play tennis and chess. How many students play both games? See them here? Both games. No, lie. This one play only thing there. Both games. I've seen this question with us. How many people play one game, you know? So both games are played by these persons in here. Both games. So it's 2 persons play both games. So this is it. But I've seen this question asked how many see it here? How many people play exactly one game? It was the same question. Right, 9 and 10. Good. So exactly one game, let me circle that one in a different color. So let me use a color to code it. The color code it here. So this one is 2 persons. But those who play exactly one game now, will be these. 1, 2, 3, 4 persons play only one game. They only play tennis. These in here, they play chess and tennis. Just like the chess set is a subset of the tennis set. So, but who play chess also play tennis. You get me? So, this one was 4. The answer for this one is 4. 4 persons play exactly one game. Ali, Alex, Kayla, Tom. All right, this one. This one says, Venn diagram shows the members of a sport club who play rugby or basketball. The number of persons who play rugby but not basketball. That is this. These play rugby but not basketball. That's 15. They play rugby. In other words, they play rugby only. All right. Next one. If the number in set A is n, m, meaning that there are m elements in the set A. Number of values in set A is m. Then the number of subsets is 2 to the m. 2 to the number of values, 2 to the m. M is the number of values in there, the number of elements. 2 to the m is something that you must know, guys. Number of subsets is 2 raised to the power, and the power is the number of elements. Number of elements in the set. 2 to the m is the number of subsets. And remember, it has 2 improper subsets. 2 improper subsets. All right. Next one. Oh, it's another question here. Q has the elements A, B, and C. This is the example that we did up a while ago. How many subsets are obtained? Since the number in there is 3, then the number of subsets is 2 raised to the n, which is 2 cubed. 2 cubed. So the answer is this one. Don't give it away. 2 cubed. The set of positive integers is an example of a infinite set. Positive integers go on and on and on and on forever. Positive integers. Positive integers start from 1. So it's 1, 2, 3, 4, 5, 6, and so on. Positive integers, which are also the natural numbers. So it's an infinite set. Go on and on and on forever. Amen. To infinity. This one is a repeat question. We did this one earlier. These two add up to 29. Plus 14 and 15 is 29. So these two must also add up to 29, or to change it. These two must also add up to 29. This time, they give us the 6. What did earlier? They gave us the 23. So for them to add up to 29, this will have to be 23. This has to be 23. Them two values, they must add up to 29. So that must be 23. But I go to that. All right. So another question here. Same thing again. So I give you this one and this one now. So these two add up now to 19. See it here? These two add up to 19. So these two also must add up to 19. Put it in blue. These two must also be equal to 19. In order for them to add up to 19, if this is 9, this have to be 10. This have to equal 10. Good? But good at that? So this has to be 10. Hope you understand that enough. If you don't understand talking, you know. Good? All right. So you see, they set this question a lot of different ways all the time. But remember, number in the individual sets must equal to the total of the union and the intersection. Simple as that. For finite sets, all right? For any two finite sets, that's what it goes. Here's another question. Y and X and Y are finite sets, such that, see here again, the number in X is 9, the number in the intersection is 4, the number in the union is 15. So if you're setting this up, they want the number in Y, right? So you're saying 9 plus the number in Y will have to be equal to the number in the intersection, which is 4, plus the number in the union, which is 15. See that? So this is about 10. See that? But it's a 19, you know. But it's a 19. This is no, this is 19. So this also must be 19. For that to be 19, this will have to be 10. This will have to be 10. So the answer is 10 for this one. Hold on a second, guys. Just lost internet a bit. Give me a second. Hold on a second. I'll come. Not sharing it. Hold on a second, guys. All right, good to go again. All right, sorry about that, guys, online. Are we back? But I can see the screen again. Very good. Online. Just checking. Micah Swaby.
Oh, yes, sir.
All right. Right, so this is another similar question. The sum of these two must be equal to the sum of these two. All right, so the number in X, that's what I thought this time, plus the number in Y must be equal to the number in the union plus the number in the intersection. And this time they gave us the number in the X, which is 9, the number in Y, which is 10, must be equal to the number in the union, which is 15. And we're trying to find this one. All right, so again, this is 19. I like these two numbers. So this also must add up to 19. So this has to be 4. So the answer for this number and this one is 4. All right, so I see that they set this pretty often, guys. You're almost certain to get one like this on the exam paper, or 2. All right. This one now says, what is the shaded area? And I've seen them ask question about what is the unshaded area. So if you read carefully, the shaded area is everything outside of P. If that asks for the unshaded area, then the answer will be P. If they ask for the unshaded area, then the answer would just be P. Let me write it out. Unshaded area. Unshaded area. Equals P. Set P. But now they ask for the shaded area, so it's a complement of P. Because the shaded area is everything outside of P. So this is the answer. Shaded area is a complement of P. Everything outside of P. Yes, here's another question. This time they ask for the unshaded area, which is inside here. That is Q only. Q only. So you're outside of P, but you're inside of Q. So it's Q and outside of P. See it here? Q and, because the intersection means and, outside of P. That's what this is. So the answer is this one. You're in Q and at the same time, you're outside of P. That's Q only. So that is that one. the unshaded area. All right. Next one. Which of the following sets are equivalent? Equivalent sets have the same number of values. Two sets are equivalent when they have the same number of members. Simple as that. The member can note. Two sets are equivalent. Equivalent in sets means that the number of members is the same. Write it out. Same number of elements. Same number of elements in both sets. In the sets. That's when they are equivalent. So this set has 4 values, don't it? So here we have 4 values in this one. So for this one, n equals 4. For this one, n is also equal to 4. So it means that those two are equivalent. That's why this is the answer. Let me put it here. So the one they gave you has 4 values in it. The other one has 4 values in it. Once you have the same number of values, they have to be the same values. Once you have the same number of values, they are equivalent. All right. We did this question earlier. This one refers to the Venn diagram below. The Venn diagram X represents the set of factors of 12. Y represents set of factors of 9. The shaded represents the shaded region. So the shaded region is the intersection. So what I'm going to do for this question is just list out the factors of 12 and the factors of 9, and then we're looking for the intersection, just to be sure. So X are the factors of 12. Factors of 12. 1, 2, 3, 4, 6, and 12 itself are factors of 12. Y, factors of 9. 1, 3, and 9 are the factors of 9. We're looking for the intersection. 1 here represents the intersection, right? Here represents the intersection. Here represents X intersect Y. So it's 1, 3. 1 and 3 alone is in the intersection. So the intersection has the elements 1 and 3. And 1 or 3 are factors of 3. 1 and 3 right now are factors of 3. So these happen to be factors of 3. So that's what the answer is. The shaded region, which is the intersection, happens to be the set 1, 3, which are the factors of 3. So the answer is this one. Factors of 3. All right, that is that. I remember this question. So last year, a session similar to this one, and we did this question. And then CSEC set last year. This one down here. So the answer is different. And somebody said, but sir, the answer was D, something like that. He said, no, it's a different question. They're asking something different. All right, so be careful. I saw the answer was B or something like that. All right, so this question says there are 30, the 30 students in Teacher May's class have either a dog or a cat or none of the two. A dog or a cat or none of the two. It says all the students who have a cat also have a dog. That's a subset situation, you know. All people who have a cat also have a dog, but not everybody who have dog have cat. So you know you have a subset situation, right? All who have a cat also have a dog. So it means that the cats are the subsets of the dog set. Because not all who have a dog have a cat, but all who have a cat have a dog. He said the number of cats is 12. The number of dogs, or number who have dogs is 17. Which of the following Venn diagram is the correct one? Represent information. So it's a process of elimination. Look how we can eliminate as we go. First, he said the number of cats is 12. Right now, this is 14. That make it wrong already. But the number in this cat right here is 14. So this make it wrong. Right here, so we have 14. 12 and the 2 is 14. They told us that the number in cats must be 12. That already made this one wrong. Process of elimination. Down here, so now. The number, so we know that this one wrong because these are two disjoint sets. But we know that the question spoke of some intersection taking place. In fact, there's a subset situation because it said all who have cat also have dog. So you know that there must be some intersection. There's no disjoint situation here. So that's what caused this one to be wrong. This one wrong for that reason. Because the information does not suggest a disjoint situation. You get me? That one caused that one to be wrong. Down here. What makes this one wrong? Same thing again. This is 14. And they told us that the number in cats was actually 12. So that makes that one wrong as well. If you look at the dogs, number in dogs must be 16. Well, this is 16. That's okay. And this is actually 18. So that makes it wrong as well. Because see, the number in here so will be 18. That's another thing that will make this one wrong. This is 18. That one wrong. How much we've marked wrong already? 3 wrong. So the answer must be the last one. The answer must be this one.
Focus.
Mute your mic, please. Mute your mic. Mute your mic, please. Mute your mic, please. Oh, Jesus. Mute your mic, please. All right, let me mute now. That must be the right one. Because it suggests the subset situation. So you say all over a cat, also have a dog. Right? And the total number in the cat is the 12 that they told us. So there, this is 12. The total number in the dog is 16. The 12 who also have cats, cat and dog. And the 4 who have dog alone. So this is add up to 16. Which they told us that was the case. And then everything must add up to 30. Everything must add up to 30. You have a 16 in here altogether. 12 on that. And then this add up to 30. So that one is correct. Everything must add up to 30. That is the correct Venn diagram for this one. All right. Then if you look at this one down here now. Same information almost. Same Venn diagrams. But the answer different. Answer is different, guys. This one says 30 students again in teacher May's class. They have either a dog or a cat or none of the two. Did they say none of the two in the previous one? Or none of the two? Means you have some people outside, right? That's what none of the two means. You have some people outside like these. None of the two. All right, so we're looking for people who have none of the two. It says 16 have dogs, 12 have cats, and the remainder has neither. So this one gives you some other information. So the remainder has neither. So it means that they have disjoint, you know. 16 have dogs, 12 have cats, and the remainder have neither. So since the remainder have neither, it means that they're disjoint. So the answer is suggesting that this is the answer. Disjoint sets. So this is it. Must add up to much? 30. Yeah, this add up to 30. So this is 16 dogs. 16 dogs. 12 cats. 12 cats. The remainder have neither. There's no intersection this time. Let me mention not about no who have cats and dogs together. That's it. Well, let's use the process of elimination still to eliminate the others. So the number of cats, number of students who have cats is 12. This right here is 40. So this made this one wrong. This made that one wrong. This one again is another 14 situation here. So when it's supposed to be 12. That make that one wrong. So it's either one of these is the answer. But the question did not speak anything about a combination. So this one is wrong as well. But this one representing a combination. Right, so that one is wrong this time. So this is the answer this time. All right, so you have to be careful. And you can set the same information again, you know, guys. As yet another set. Another Venn diagram is the answer. You have to be careful. All right. So what happens that both of them is D. All right. But the person was saying, but sir, you said that this diagram was the right one. I said, no, the information different. Right? Information has small changes in it. So you have to be careful. All right. So don't go thinking it's the same. I know a lot of you do that. So careful. All right. Next question. Which of the following Venn diagram is A intersect B complement? This means that you're inside of A and outside of B. And it must be shaded. This really means A only, you know. This means A only. That's a simple way to say this is A only. A only. Looking for the section that is A only. Because you're in A and at the same time outside of B. You don't want any part of B. So it's A only. So see to yourself, this is A only. Only A only is shaded. See? No part of B is shaded. So you want to be in A, but you don't want to be in B. So this is the answer right here. A only. That is it. A only. Hope everybody get that. Why is this one not the answer? Because this has some B in it. And this set has B complements. You can't have any part of B in it. B complement means that you don't want any part of B. So that cannot be the answer there. Right? A lot of people might be toggling between these two. We cannot have any part of B shaded, but the thing has B complement. That's B complement, means I don't want any part of B. So it actually means A only. This one will be B only. So if I were to write what each of them is, right? If I were to write the set notation for each of them, in case I change the question. This one is B only. So this one will be B intersect A complement. That's what this one is. This one is just set A. So this one will just be set A. Because only A alone is shaded. This one is what we just said. This one is the A intersect B complement. That's what this one is. And this one knows what? A union B. A and B together. A union B. A and B. A and or B. If you have the intersection alone inside here, so that is A intersect B. Note the difference. To draw A coming on the exam paper. So them on the screen. It will be inside here shaded. That one will be A intersect B. A intersect B. Put it in blue, Mr. Shaw. This one will be A intersect B versus A union B. So that's what A intersect B looks like versus A union B. So don't know what's coming in the exam paper. I can ask you any one of them. All right. I can give out the same 4 diagrams, you know, but ask for a different set, you know. Ask for a different combination. So it's good to know all of them, right? Because I could easily come now and change around these 2 letters. And then the answer will be this one down here. Right? Answer will be this one. And remember, no, this now can also be written as this, you know. Look, you see this one can be written as this as well, you know. You can put them another way around, and right? A complement intersect B. This and this is the same thing. It can be read from left to right or from right to left. It can be read either way. So this and this is the same thing. Still intersection between the sets B and A complement. No matter which one you put first. It's the same. So they could give you this question now instead of this. And then the answer will be this set instead of that one. All right, so look out for that. Anyway, I think we're done. Wow. Wow, we're done a couple minutes to 2, and I said we're gonna finish at 2. Beautiful. Beautiful, beautiful, beautiful. That is that. All right, guys. We're gonna end it now, and we're gonna start back tomorrow at 11. I was starting back tomorrow with consumer arithmetic. And I know consumer arithmetic for some reason give a lot of people problems. All right, we're gonna do consumer arithmetic and which other topic tomorrow? Consumer arithmetic and algebra. I think we're doing tomorrow. We're doing 2 more topics tomorrow, guys. Okay, online. See you tomorrow, 11 a.m. Taking it in stages. I suggest that you go back to the video. It's gonna be on my challenge online. Go back to the video, look back at some of the questions. Work them out yourself. If you're not so sure, I can send me a message. Bye, everybody.